Okay, so here's an example of how to solve a system of equations. As you can see, we have three different variables, and we're looking for the solution that would satisfy each of these equations. And what we're going to do is we're going to keep track of the coefficients. How many of these things do we have? Because it doesn't matter if you call this x, it matters that we have one of them. And that in this particular example there are two of these things, and in this particular example there are three of them. So again, it doesn't matter what you call them, we're going to keep track of how many. And we're going to make an augmented matrix. And an augmented matrix simply means that you're keeping track of both the coefficients as well as what the solution is to that particular problem. So in this case I have 1x, I have negative 1y, I have 1z, and my solution is 8. In this particular row, I have 2 x's, I have 3 y's, I have negative 1z, and I have negative 2 as the solution. And in this row, I have 3 x's, negative 2 y's, negative 9 z's, and 9 is my solution. Again, the first three columns would be the coefficient matrix. This happens to be the solution matrix that we've augmented or put together. And you'll find some textbooks may even put a line there to separate. These are the coefficients and these are the solutions, but it does not matter. As long as you keep track of order, it doesn't matter if you put that line there or not. Okay, so again, this is what we're going to work with now. We're kind of removing ourselves from this equation because all we're interested in is how many of each variable do we have. Now, we're going to take this matrix and we're going to transform it, and here's our goal. Our goal is to transform it into a matrix that looks like this, where the first row is 1, 0, 0, and then there's an answer. Call it x. And then 0, 1, 0, and then an answer, y. And then 0, 0, 1, and then some number, z. Because if I can take this matrix and transform it into this matrix, this equation would read 1 of these variables is equal to that number. And 1 of these variables is equal to that number. And 1 of these variables is equal to that number. In other words, this then becomes our solution. Here's the x value, y value, z value. Okay? If you can get this diagonal of 1s and 0s everywhere, that is called a row-reduced echelon form. And it doesn't matter that you know what that's called, but I guess it kind of does because I will refer to it. Row-reduced echelon form. Okay? And an abbreviation, sometimes you'll see it as RREF, row reduced echelon form. This is our goal. And so the whole point of this exercise is how do you take a matrix here, which again represented our equation, how do you take that matrix and transform it to it looks like this? And what we're going to do are simple, I guess, mathematical rules where you're adding or subtracting or multiplying the same thing to both sides of the equation. We're just not looking at the equation, we're looking at the matrix.